So you need a little bit of instruction before you can begin this homework assignment. I talked a little bit about this in the last video, that there is a difference between something that is growing continuously, okay? And this equation, this is perfect for like bacteria in a petri dish, right, where it is continuously growing, all right? Whereas this formula, I might use this when I get an annual raise, okay? Because I'm not getting my money continuously. At the end of the year, I get this lump sum added to my base salary, okay? And so that's how, this is the formula that I would use if I get a 3% raise annually, okay? Is then the next year I get this amount dumped into my annual salary that then I get divided over my number of pay periods. Okay, so if Bill gets a 3% raise annually, which formula is better to model his pay? So exactly what we were talking about, this one, all right? You would be using this formula where his pay after X years, right? So you would take his base pay, doesn't matter what it is, right? Base pay, so I'll use P, right? And then every year you take his base pay and add 3% to it. But then the next year you take this amount, right? This amount, multiply it again by this 1.03 factor, right? So then how do you generalize that into a formula after X years? So I'll leave that for you. Now, in number 2, if we compound continuously, then that's this formula. And if I find the value of the investment after 1 year, all right, so I'm going to let you do the work, but I am going to tell you that, well, actually, let's compare, okay? If you invested $1,000 at 6% per year for 1 year, and at the end of the year, money was just dumped in your account. You got it at a lump sum. You know, you invested on January 1st, on December 31st, you get money deposited into your account of the amount of $60, right? That's if you had used this formula up here, right? That's the result. You would get $60. However, if we use the formula, we should, since it's compounded continuously, right? So we should use the formula up here, this one, right? If we compute that, we end up getting 1,000. At the end of the year, it's worth $1,061.84. The good news is if you ever use the wrong formula, the answers you get to these formulas are very, very close. That's why sometimes they get used interchangeably when they shouldn't, because there is a subtle difference between the two formulas. But the answers that you get tend to be very, very close. And if we're going to round off anyway, we might really not care. And we might be just as happy with the answer we got from one formula versus the other. But anyway, if I wanted to find the percentage growth of the investment after 1 year, the annual percentage yield, okay? So I'm getting 6% compounded continuously. So really, at the end of the year, I have earned more than 6%, right? So when I find this annual percentage yield, I have earned 61.84. $61.84. That's what I earned. So if I look at the percent increase, you had this on prerequisite skill from Monday. The percent increase is equal to the amount of increase, right? So I'm not going to even try to do that. I'm going to just write it with the numbers. The amount of increase, which is the 61.84, divided by the original amount, which was 1,000. And we don't need our calculator to do this because 3 zeros, move it over 3 places. So my annual percentage yield is this, right? Which as a percentage is 6.184%. Okay, so that's saying if I had done the whole dump it in as a lump sum at the end of the year thing, then the interest I earned was 6.184%. But since it was compounded continuously, right, an interest rate of 6% compounded continuously gives me the same amount of money that a 6.184%, lump sum dumped in at the end of the year kind of thing would give me. One more problem that I want to do with you. So the rest of these problems are similar to this, finding an annual percentage yield again. Let's look at the inflation rate and how long it takes for the consumer price index to double. So that would be a pretty high inflation rate. That would not be good for our economy. And if we want to look at, if we think about this inflation rate, like they measure they find the CPI January 1st, and then they find it again January 1st of the next year, and it's gone up 7.5%. That would mean that we should be looking at this formula, right? So we would have whatever the amount was this year. So I'm not told of a starting value, so I just call it Q naught. Right? Whatever Q naught is, then I have that amount plus because it's gone up by 7.5%, so I have the 100% of what it was plus this. And I'm looking for when is that going to double? So I don't have to know my starting value. I'm looking for that to double. I'm sorry, I should have a T raised to the T. All right, so T would be my time in years. I should write a let statement for that. Let T be the time in years. We talked about in the last video how important it is to know the units on T. So I don't have to know where I started. Whatever I started with, that's fine, but I'm looking for it to double, right? Well, look what happens. These cancel. Okay, so then all I'm doing is solving this equation, and I just realized something. We don't have the tools yet to solve this equation, because in an upcoming lesson, you know what? Why don't I mark this problem then as a weight, okay? Because what we would do, we would take the natural log of both sides. And what you haven't learned yet, although you might remember it from high school, property of logs say that the exponent drops in front. All right, so that I would actually end up getting T equals, right? I would have natural log of 2. Right, because the T would drop in front, and then I divide both sides by natural log of this 1.075. That's how I would do it, using laws of logs, which are actually Monday's lesson. But luckily, number six is very similar to number 5, except you're going to be compounding continuously. So with the other formula, we've already worked on taking the natural log of both sides, and there's no additional laws that need to be used. So it doesn't tell you how much money is invested, but remember, that doesn't matter, right? If I want it to double whatever I start with, I have twice that on the other side, and I cancel these off both sides. So if you get clever, right, if you notice this pattern in repeated reasoning, you might end up getting nice, easy equations where you just say, oh, I just have to write 4 equals e to the, KT. All right, those are that simple. So I'm going to leave the rest for you because I don't want to spoil your fun. And actually, I think that's all of the things that I need to go over with you. I think the rest of this sheet you should be good to be doing on your own.